Hi everyone, welcome back to another Calculus 12 video. Today we're doing 7.5, which is inverse trig functions. And I've already written some of this out to make this a little bit quicker and easier to fly through. So I'm just going to start with this little bit. You've seen this before, just maybe not with trig and maybe not in this format. But basically, if we have some function f of x and we compare it to this notation here is indicating that we're working with our inverse function, the inverse of f of x. So basically they're like opposites. So whatever you had happen with f of x, this inverse of f of x will do the opposite or undoes what f of x did. So a way to put this all together is if we take a look at this and say if we take our inverse of f of x, if we multiply it by the original f of x, so let's maybe do it this way, inverse of f of x, if we multiply it by the original f of x, then you would get, it's like you're inputting one into the other, and everything would end up canceling, and we would end up getting an end result of just x. So everything else within the equations would cancel, and you would just be left with x in the end. So that's the basic idea behind it. I think just to help make sense of it, we'll start out with the non-trig function, something pretty basic, our usual parabola, and then we'll apply those concepts using trig afterwards. So, first thing to remind you is if this is my original function, I taught you, or depending on if you had me for pre-calc 12, somebody taught you to write y equals x squared. You don't have to do that, but just to keep track of things and to know what's going on here. Then the next step is we would swap our x and our y. So we would actually have x equals y squared when we swap things like that. And then the next step is we would want to isolate our y value. So root x is what we would end up getting for our y value. So I could say that my inverse of f of x is equal to root x. So that's what we're getting here. So if I were to, let's substitute in a value to check this out and to make sense of this concept in the box here. So let's say if x equals 3, then f of 3, like in our original function, we can tell by looking at it would be x squared, which is just 3 squared, which ends up giving us 9. And if I did the inverse of f of 3, so this is me putting them together like this, like composite functions to remind you from pre-calc 12, then I would get the square root of 9. So therefore, the inverse of f of 3, when we put it all together, just ends up being the number 3. So this 3 that we had input in there is what the answer ends up being. And that's how this is all sort of put together and how it makes sense. You could have also, or we could have also done this just using the x's, like taking root x down here and plugging that back into the original and working our way through it that way. Take your pick. They all mean the same thing. If you'd like to choose a number like I did to plug in to test it out, you can do that. If you'd like to work with the algebra and the x's, you are welcome to do that. Okay, so then therefore, if we're dealing with trig functions, I've put it into the box here so that you can just refer to this or look at this, but if we're taking the inverse of sine x, it all cancels and just leaves us with x. You get the idea. They're all the same. Inverse of cos x is x, and same thing with tan. So using or applying that principle, let's go through a few of these. If you take a look at, like, this is just a matter of looking at what we're dealing with here. If x is there, then that's what we're left with, because to have the original f of x and then the inverse of it are total opposites. So I'm just trying to clearly show you that that just means that we'd be left with the pi over 2 after working our way through that. So hopefully that makes a bit of sense and helps you to understand things a bit. On to the next one, because this is looking a little bit different. If we take a look at the rule here, I kind of want the stuff inside here to be in terms of sine, not cosine. But sine and cosine do have a relationship with one another, so we can actually use our knowledge of that, and maybe I'll call this all m. I'm just picking any variable, doesn't matter what it is. But let's over to the side here. Let m equal cos of -1 of a half. Let's build in some review because it's been a while and maybe you don't remember this, but just to remind you from our special triangles, because I recognize this ratio, 1/2 in your mind should trigger the ratios from the special triangle. But remember in our special triangle, we had this 1, 2, √3 thing going on. And at the bottom here, we had pi/3. And the other one up here, I'm not going to write it, but you know it would be pi/6. So if we're dealing with the inverse cos of 1/2, then cos of m is equal to, sorry, I'm going to write it below. Cos of m is equal to the cosine of inverse cos of 1/2, like this. Sorry, you can't even read that. Let me rewrite that so you're able to read it. So cos of m is equal to 1/2. So where is this I feel like I didn't do this clearly. Let me redeem myself. Let m equals this. So basically like this. Color coding's not working either. So then if I'm doing cos of m, then it makes sense that it's cos of all of this stuff. That's what's happening here. So I hope that helped to clear it up a little bit. And so if it's equal to 1/2, then from our special triangle here, we know that means that our m value must be equal to pi/3 because we know that cosine is adjacent over hypotenuse. So it's adjacent to this little angle here that I have 1 and the hypotenuse is 2. That's how I know that it's pi/3. So taking it back to up here, oh my goodness, I feel like this is the worst video I've ever made. Sine of pi/3, because we substitute that, like we found this pi/3, we're substituting it back into what we had there, and that sine of pi/3, again, I can just use this over here. If I'm wanting sine of pi/3, I know sine is opposite over hypotenuse, so it'd be that pi/3 over 2, or √3 over 2 is our overall answer. You might have to pause that and replay it. So that is that example. Let's do another one because I don't know if you got that. So, okay, there's a bunch of stuff going on here. So the first thing is, and I hope by now you've started recognizing this pattern, but notice that it's cos squared and then inverse sine x inside. But I guess for me, when I see cos squared, I think trig identities, the Pythagorean trig identities, because anytime you have sine squared or cos squared, that's what you would think of or look to. And just a reminder that cos squared x plus sine squared x equals 1 is that Pythagorean trig identity. If you want to use a formula sheet for this, I have them and I'm happy to allow you to use that, but I figure by now you probably kind of have this memorized because you've been practicing with this for a few days. So it's fair to rewrite this and say cos squared x is equal to 1 minus sine squared x just when we rearrange these. So I would just take that and move it to the other side. But by doing that, it's allowing me to work with this. Since it's 1 minus sine squared x, I can take this overall thing here, and instead of making it cos squared, I can make it 1, so I'm going to take this and do 1 minus sine squared, and then instead of x, my x is all of this stuff. So it's going to be inverse sine of x. Step back, look at the big picture. Instead of using co-squared of that blue stuff, I've done 1 minus sine squared of the blue stuff. Because of right here, we know that they mean the same thing. Or I guess that was the original, but maybe because of right here, we know that they're the same thing. So I have just taken out the co-squared x, and I have just substituted that part in instead. So I hope that you're able to recognize that, or that it makes sense so far. And then thinking our way through or applying that rule that we learned, I still have the 1 minus all of this stuff here. If you look at it, we're dealing with opposites here. So sorry, I could have done this. And it's just equal to x squared. So after all that work, I just have 1 minus x squared, because all of this stuff, they're opposites, so they cancel one another out. They're inverses, so they cancel one another out. Okay, which only leaves you with the x that was here. Your assignment or your work for this section is page 334, 1 to 4 all, and number 5 odd letters. If for 1 to 4 all, you feel like you've gotten the hang of it and you want to do odd letters, your choice.